Hello, students. We are taking a look at the mathematical connections for 5.1. So these MCs are, there's not a, I don't think I gave a ton of time, 3 through 5, and then some of the classroom ones. So 3 through 5, explain why B minus A and A minus B are additive inverses of each other. So just remember, if you're going to think about this, right, go back. What's the definition of an additive inverse? Okay. So 3 and -3 are additive inverses. Why? Because when you add them together, you get 0. So that's a hint for number 3. Number 4, I did talk about this in my video about the entire section. When we talk about the definition of absolute value, it says the absolute value is never negative. Okay, so that is definitely true. And sometimes, though, what they said, if you were following along, it said the absolute value of x could equal this. And so again, is this a contradiction? You said the absolute value could never be negative, but yet you wrote something like this. Make sure that you kind of address that component. And if an integer is pictured on a number line, then the distance from the point on the number line represents the origin is the absolute value of a. When they say the origin here, they're referring to the number 0. So the absolute value of a is like the distance from a to 0. Using this idea, explain why absolute value of a minus b is the distance between the points that represent a and b. So again, absolute value of a gets you distance from 0. When you're doing something like a minus b, we're not talking about a distance to 0, or since you could be, it's just the distance of a minus b to 0. Okay. So how far is it from a minus b to get back to 0? So now again, if you think about that, and you may have to kind of do this on a number line to help you kind of understand what's going on. But if you do, let's see here, here's 1, 2, 3, 4. So for example, the absolute value of 4 minus 3 is supposed to indicate the distance between the points. Okay, so whatever this thing is, 4 minus 3, its distance to 0 would equal that value. And so the distance from 0 of 4 minus 3 would actually be, so if you actually go through and do the operations, you'd say the absolute value of 1, okay? Because it's this distance here. But what they're really saying is you could represent this as the distance between the numbers themselves, the distance between 4 and 3. And that's what they're getting at with this connotation. It's still 1, but it looks a little bit different. It feels like it's in a different place. So that's 3 through 5. Let me do a quick little check again, what I say, and 11 through 15. Okay, so number 11, discuss the differences in the use of a minus sign, that symbol. So again, there's 3 ways we can think of it right now. We have it as a negative integer, like -3, subtraction, like 3 minus 5, and the opposite. Okay, so we have 3 different ways that we think about it, and they're asking you to kind of list out what are the differences? When would I use it? What does it represent? Let's see here. Actually, 12 is kind of a fun one. It's talking about an elevator going up and down, and after a while of some ups and downs, you end up at the top floor. After a while of some ups and downs, you end up at the bottom floor. Do a little bit of problem solving strategy to get to the final result there. And let's see here. Question 13, this again is one of them, is very similar to what we did back in a prior unit. This was with subtraction back in 3.3. So again, think about what the student is doing as they're doing subtraction and getting to a negative value. Is this okay? Will this technique always work? And if you were kind of doing the other ones on your own, you probably already have the answer to that. Let's see here. 8th grade claims she can prove subtraction is commutative. She says a plus negative b is the same as a minus b, and addition is commutative, so therefore subtraction is commutative. Think about how, I mean, God, the student is very bright then to kind of start making those connections. that doesn't mean they're correct. So let's see if we can kind of put them not in their place, but help them to understand why that may or may not be the case. A student had the following picture saying, hey, here's an integer and here's its opposite. Another student said, no, you can't have that. The negative should be to the left of 0. How do you respond? Take a look at that and see if you have an issue with this or if you have a better way to do it. And I think that's it. Does that take us through 15? That takes care of it. So not a huge amount for this one. I think the biggest piece for most students is just getting used to the symbols, probably. The idea of the opposite symbol, which this book writes a little bit higher than a subtraction symbol. Not all books do, not all calculators do. So you have to understand how your calculator works as well. All right, that's it for this. Have a great rest of your day. Off you go.